Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Twin Chaos Constructions. X sums in two ways. It's a 2 by 8 by 8 by Playmaker6174. Here are the rules. In this puzzle, two 8 by 8 grids are given side by side and are meant to be solved together at the same time. Chaos construction rules apply to both grids. For each grid, every row, column, and column contains digits from 1 to 8 each once. That's a very weird way of putting it. For each grid, every row and column contains digits from 1 to 8 each once. 1 to 8 once each. Once each, right? I don't know. I don't know. Maybe that works that way too. And the grid must be divided into exactly 8 orthogonally connected regions so that every region will contain the digits from 1 to 8 once each as well. Yeah, each once is kind of weird. 1 to 8 each. Yeah, once each. It should be once each. Each one, I can't even say it because it's weird. Each once is kind of a weird way of putting it. I think, yeah. So for every grid, every row and column contains digits from 1 to 8 once each. And the grid must also be divided into exactly 8 orthogonally connected regions so that every region will contain the digits from 1 to 8 once each as well. Yeah, it doesn't make any sense as each once. Yeah. What is the each referring to? It's anyways. What is an orthogonally connected region? It means a region that you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. So for example, to get from here to here, you can go through these edges while staying within the region. What is not valid as an orthogonally connected region would be something like this, because even though these two cells can go to each other by going through edges while staying within the region, they cannot go to any other cells in the region just by going through edges while staying within the region. They would have to go through a corner here, or exit the region by going through an edge, neither of which are allowed. So that's how orthogonally connected regions work. Two caged cells contain two digits with different odd and even parities. So these two cells have to have digits of opposite parities. One of these is going to be odd, the other one is going to be even. So that's another rule. For any pair of two cells with gray squares in the same relative position from both grids, one of them counts how many cells it sees horizontally, including itself, while the other counts how many cells it sees vertically, including itself, where region borders and 8 by 8 grid borders obstruct vision in both cases. So basically, it's just the number of cells. So this one of these cells in this puzzle must count the number of digits in the same region as it, essentially, in the same row, which is horizontally, while the other counts how many cells it are in the same region as it, vertically, which must also include that cell itself. So it's basically cells in the same region, horizontally and vertically, for both of these cells. And one counts the horizontal that are in the same region. The other counts the vertical that is in the same region. Okay. Rules for the outside circle clues next to the grid. For the left grid, each circle clue acts as a regular X-sum clue. Its contained value is equal to the sum of the first x digits from the same side in its respective row and column, where x is the digit next to that clue. Additionally, those x cells must belong to the same region. And the x plus 1th cell right after them must belong to a different region. So, for example, if you had, say, 3 here, that would mean the next 3 digits add up to 16. Actually, is that even possible? Yes, I guess it is. So these 3 digits would be in the same region. And then the next cell after those 3 digits would have to be in a different region. So you could have something like, say, 3, 5, and 8, and that would work for this xsum on the left grid, and this would have to be in a different region. For the right grid, each circle clue acts as an opposite xsum clue. That is, its contained value is equal to the sum of the first x digits from the opposite side in its respective row and column, where x is the digit next to the clue. And the x plus 1th cell right after them must belong to a different region. So say, for example, we had 3 here. That means in the opposite end of the column, these 3 digits would have to add up to 16. So you could have something like, I don't know, 7, 8, and 1 here. And that would be valid. So then these 3 digits would be in the same region, and this cell would have to be in a different region in this grid. We also have any 2 pair of outside circles in the same relative position from both grids must contain the same values. For example, if the clue in the top of column 1 from the left grid contains the value 12, then the clue on top of column 1 from the right grid must also contain the value of 12. And the question mark 0 clue means its value is a multiple of 10, which I assume has to be 10, 20, 30, 40, because 0 is actually a multiple of 10 also. I think technically. Is it actually? I don't know. Maybe not. Maybe not. Maybe 0 is not an actual multiple of 10. But I'm assuming that it's going to be a 2-digit sum here. And it must be 10, 20, 30, 40 for that to work. Actually, it can't even be 40. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. Oh, one thing. Okay. How is this going to work? Well, 16. We have 16 quite often, and we have 18. To add up to 16, it's going to have to be 3 and 4. Right? For regular x sums. Because 3 and 4... you can't have 5 digits. You can't have 2 digits adding up to 16, right? 2 plus 8, actually, because this is 1 through 8. 2 through 8 adds up to 10 at most. You could have 3. Obviously, we did it with the example here. 3, 5, and 8 work. You could have 4. but you cannot have 5. Because even though you can have 5 digits adding up to 16, they don't contain a 5. So this is guaranteed to be 3 or 4, and this is guaranteed to be 3 or 4. And so is this, because they add up to 16. What about 18? 8, so this is for regular x sums. For opposite x sums, you could have 3, 4, or 5. Because 5 can actually now be in the row, because it's the opposite set that's adding up to 16. And so you could have 1, 2, 3, 4, 6 adding up to 16 there. So the remaining digits in the regular x sum, so this is guaranteed to be 3 cells here. This is guaranteed to be at least 3 cells here. Okay, adding up to 16. What about 18? 18 can it be 3? 3, 7, and 8 add up to 18. So yes, it could be 3. You could have 4 or 5 adding up to 18. You cannot have 6 because the minimum of 6 digits is 1, 2, 3, 4, 5, 6, which adds up to 21. So this is 3, 4, or 5 here. Same with this has to be 3 at least. So we have 3 going that way. We have 3 going this way. This must be at least 3, so we'll have 3 going that way. Oh, that's interesting. This again is 3, 4, 5, but this has to be the same region. So we're going to make that not yellow. We're going to make that red. Therefore, this must be 1, 2, 3, 4, 5 here. So this can no longer be 5, actually, because if this were 5, this would be size 5 as a region. But these 2 cells don't have a region. They must belong to this one. So therefore, we have 1, 2, 3 here. So this must not be... This is 4 at most this way, because we already have 7 cells in this region. So this cannot be 5 here. It's 3 or 4 there. Okay. That's interesting. So the digits here can be up to 5. So this could be to technically 1 through 5 there. And this could be, can it actually be 1 through 5? Can it be 1? If this is 1, this has a value of 1. But then this would have to be 1. This would have to be value of 1. And there's no way that that has a value of just 1 by itself. So this cannot be 1 here. This could technically be 1, though. Because you could have 1 there. So this can't be 5 either for the same reasoning, right? If this were 5, these 5 would have to be in the same region, but we know these 3 are in the same region. Okay, so then what happens if both of these are 3? What happens if this is 3? If this is 3, this becomes 4 and 4. So this must be a region of 4. This must be a region of 4, but that's too large because that is already 9 cells when each region here is 8 cells. So this cannot be 3 here. This could be 3 and 3, though. That would be fine. This is 10 at least, so it's at least 2 here. It could be 3. I think up to 7. Yeah, 2 through 7 there. And I think this is also 2 through 7. So we know these 2 cells are in the same region. These 2 cells are in the same region. They could be part of this. We don't know. Oh, this is at least 4, so this must be part of this. So this is... I guess we'll make this blue. Because this is at least 4. This... Well, we don't know. One of these digits is at least a 3. Right? Because if this digit is 3... If they can't both be 4 because of how we showed that, right? Then this would be 4, this would be 4. That would be 9 as the size of a region. So one of these is 3, so this cannot be 3. We have 1, 2, 4, 5, 6, 7, 8 there. The sum of these digits in this row is guaranteed to be 16 plus 17 minus the digit that's here. Sorry, 16 plus 18 plus minus the digit that's there. So that's at least 34. Oh. This sees cells that add up to... So this has to be a 3-4 pair here. Because these digits are in the same region. So I guess we'll make this medium. So we have a similar situation here as we did here. These two cells cannot be part of a different region. So they have to be here. But we are guaranteed that this has to be a 3-4 pair, guaranteed here. We don't have anything similar here. So one of these is going to be... So we know, first of all, this is a boundary. This is a boundary. This is a... Oops. This is a boundary, and this is a boundary. Because this is going to be... This has to be either 3 that way, which makes... if this is 3 that way, that's 4 that way. If this is 3 that way, this must be 4 that way. That's interesting. So the rest of this box, or this region, can be 1, 2, 5, 6, 7, 8. Okay. We know, so this is at 16, this way and this way. And you subtract this digit, so there would be 32 minus this digit is equal to what this sum is. The total of the digits 1 through 8 add up to 36. So one of these is going to have to be 3 to add up to 16. So it must be 3 with 5 and 8, or 3 with 6 and 7 here. So this digit then has to be 5, 6, 7, or 8, right? That's interesting. 32 minus 5 at least is 27. 36 minus 27 would be 9. So then these two digits could add up to 9 have to add up to 9 at minimum. But this can never actually... I don't think this can... yeah, remaining digits in row 1 also have to be 1, 2, 5, 6, 7, 8 for the left grid. So again, for 3 digits to add up to 16, it's 3, 5, with 3 being in one of the digits. It's 3, 5, 8 or 3, 6, 7. What are the other possibilities? Um, hmm. 358, 367. So let's say, okay. What happens if the 8 is duplicated? So 385, that means this is 4. The other two digits would have to be add up to 4, which would be 3 and 1. Because the only two digits which can ever, unique digits which can ever add up to 4 are 1 and 3. But we already have a 3 in the box. So that's not going to work. So 8 cannot be the duplicate digit here. What about 7? 7 I think might work. 3, 7, and 6. That would be 4. The remaining digits would add up to 5. No, that doesn't work. Because it can be a 1-4 pair adding up to 5, or 2-3 adding up to 5. But neither of those work because we already have 3 or 4 accounted for in the region. So that's not going to work. So this cannot be 7 here. Therefore, we have a guaranteed 5 or 6 here. Okay, what happens with 3 and 6? So 3, 6, 7 forces this to be 4. The remaining two digits would have to be 1 and 5, and that does work. And then this would have to be 2 and 8 to add up to 10. In whichever direction this is working, right? Because we have 16 minus 10 is 6. We already have 4 in the region, so we can't have 2, 4, so it must be 1, 5, which would force us to be 2, 8 as a region. Okay, so that's a possibility. Oh, this is guaranteed to be 2 digits. So that would work then that way. So if that's the case, so this is guaranteed to be 2 no matter what, actually. So we know this is 2 for counting these two digits, because in this region, we can't go further than 1. This has to be 2 or 3 here, because this is only can be 2 or 3 digits in that direction. And it has to be either 5 or 6. So this is also either 5 or 6, 2, interestingly enough. So we know 2 cannot be in the rest of the region and the rest of the column. So we know this does work as 6. So we would have then one of these is 7 and the other one would be 1, 5, and then this would be 8 in that case. What about 5? Can we have 3, 5, and 8? That would make 4 there. Remaining digits in that row, in that set of 4, adding up to 16, is 16 minus 9 is 7. It would have to be 1, 6 in that row. So either of those could work. So this is then 5 or 6. This has to be 1 and 6 with 8, and 1 and 6 with 8, and then this would be 7 there. That's interesting. Okay. So this cannot be 2 here. So it's at least 3 digits long. If this counts horizontal, it's just 2. If it counts vertical, these would all have to be part of the same region. So it could count 4. So this is 2, 3, or 4 here. Okay. If this is 3, now that's interesting. This is 3, that's 4, this is 5. That means this has to be 3 there. This is 4 cells there. That's a contradiction because this would have to be 3 cells in the same region. This would have to be 4 cells in the same region. We'd have to have 3 cells in the same region here. And that's a 9-cell region. So this can't be 3, it's 2 also. That eliminates 2 in the rest of the row or the column, so this must be 3 that way. um, hmm. So if this is 5, this is 2, 3. This would have to not be 2, 3. It would be 1, 4. So that kind of works. If this is 6, this would be 2, 4. And then this would have to be 1. So this is 2 guaranteed here. So that's the edge of the boundary there. If this is 4, this becomes 3 and 3, and that still could work. You could go here, you could go here. So this, if this is 5, this becomes 1, 4. If this is 6, this becomes 1, 5. So we're guaranteed a 1 here, which eliminates 1 in the rest of the region. Hmm. So what happens if this is 4? If this is 4, this becomes 3. This would then be 3 with this being no 5 or 6. It would be 7 or 8. This would have to be 1, 4, 5, 6. Can this... Oh. Okay, well that's... Let's not continue down that path. Let's go here. Can this ever be 4, 5? The answer is no, because then it would be part of this region here. And we'd have 6 cells here, which cannot form a full region by itself, and then, but all of them can't be part of this green region here. So this has to be 2 or 3 here. Huh. So this would have to be green. This is possibly a different green than this. So let's make this, I guess, light for now. It's gonna make it hard to see, but if this is 4, that forces this specifically to be green. Because they can't be a different other region. For this to be a different region than green, it has to go out that way. So that's potentially possible. Huh. This can't be 7 anymore because that region as a whole, we have 3 here. So that's 4, 5, 6, 7, 8. So this is 5 at most this way. Ah, we have a 1, 2, 3, 4, 5 quintuplet in column 1, which eliminates 1, 2, 3, 4, 5 in the rest of the column. So that leaves this as 6, 7, and 8. Interesting. Hmm. This is size 2 or 3. So this could be it could be 3. So the range here is 3 to what? 3, 7, 8, which is 18. 3 to 18. Okay. So this could be 3 to 18 also. This can't be 1 anymore. Okay. So this cannot be size 3 by itself. It could be, this is 4 at minimum. So this is 4 at minimum also. But that's not going to work. It can't be 4 because that would just be 3 and 1 adding up. You can't have 2 3 digits adding up to 4. So that leaves this not as 4 as minimum. It's 5 as minimum. So that's 5 at minimum. Hmm. Hmm. This digit could be part of red. So it could see 2 or 3 in that instance. It could also be not part of red, in which case potentially it can't really see 6. It could potentially see 5 though. If it sees 6, again you have the same problem of these 12 cells. None of this can't be a full cell region by itself, and it can't all be part of this region. So this is up to 5. Hmm. Hmm. Can we actually have... I guess we could have 6 here. 36 minus 30 would be 6 in those two cells. It would be 1, 5 or 2, 4. What else do we have then? Hmm. 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 Um, is this possibly not part of this? No. The only way that happens, again, is if this is 1, it's not part of that region. This would have to be 1, so then this would not be part of that region. But then the problem is this would have to also be 1 in value. And the 1 would then have to be here, but then this would not have, that would not be the sum of the first 1 digit. It would be multiple digits. So this can never be value 1. So this, since this can't be value 1, these has to be part of the same region. And therefore this is part of that region, guaranteed. So this must be at least 2. So it could be 2. We have 5 here, 6, 7, 8. But then this has the same problem of it can't be 1 either. So we can't have 5 going there. Because then this would be size 1, therefore it'd be 1 in value, which means that's 1 in value, but this is no way this is adding up to 1. This has to be at least 6, 7, or 8 in value. This is 6, 7, or 8 in value, which means this has to be at least... So this is minimum 6, 7, or 8 in value. So let's do that as 6 there. This is 6 at minimum. So it must be at least 2 here. Technically, through... You could technically have 8. That's unlikely, though. No, you can't have 8. In fact... Yeah, if this is part of that region here, you can go 1, 2, so 4, 5, 6, 7, 8. So that's 5 at most. If this is not part of that region, then this is 3. That makes that 4. And again, this can't be part of that region. So this would be 5 at most. So this has to be 2, 3, or 4 in size. Because again, cannot be here because that would block this from being part of the region. And that doesn't work. So this is definitely these 2 cells, at least as part of the same region. If this was 5, that does kind of work. Because you could have a 1 here, and then that would be 6 in value. That's potentially possible. Can this actually be 5 here? If it's part of the dark region, the answer is no. Again, we'd have 12 cells here. You can form 1 full region here, but you can't form 2 full regions. And the only part of the regions that this could be then can't be part of the dark if this is 5. And it can't, only one of these can be part of this dark gray region or medium gray region. So that would leave 11 cells remaining, which can't form 2 full regions. So this cannot be 5 here in that sense. And if we had dark, if this extent were not part of dark, I guess we could have 5 that way. So then if this is not part of this, you could have all 5 here. Dark has to have 5 more. Medium, oh, okay, that does not work. Medium has to go here because this is 3, that's 4. But the thing is, we have 7 cells here, which are not part of a full region and cannot be extended to the orange. So yes, we cannot have 5 here. Okay, so that's 2, 3, or 4. Huh. Okay. This could still be 3 if this is 4. Hmm. Ugh. So we know these add up to 18. The remaining digits in this row must also add up to 18. But that's not too helpful right now. Mm-hmm. So what happens if this is 5 here? That means this is full. So this adds up to 16. Which means the remaining digits must add up to 20. Oh, that's not going to work. Because if we have that adding up to 20, well, we also have problems with the geometry because we have this already as a region, and it can only get 1 more here. That leaves either 12 or 11 cells trying to form 2 full regions, which is not possible. So that can't be 5 here. So can this ever actually add up to 30 then? I think the answer is no. You couldn't add up to 30 anyways with just 5. Right? 8, 7, 6, 4, and 3 adds up to 28. So that's not going to work. So this is always going to be 10 or 20 here. So this cannot be 7 here. You cannot have 6 here because that only adds up to 21 or more, which would force that to be 30. So this is 3, 4, 5. So this is 10 or it's 20 as a sum. So it could be 4. That could work fine. Can it actually be 3 here, though? If we have 3, that means this is guaranteed to add up to 10. 3 unique digits. Well, that's not true. You could have 5, 7, 8 adding up to 20. Oh, okay, so never mind. So even if it's 3 here, you could add up it for the opposite x sums. It could be 10 or 20. 3 unique digits for x sums can only add up to 10. Hmm. Can this actually be 378? I don't think so. 378 means this is 4. This would be 3. So then we have 7, 8 as a pair there. I guess it could work, and then you could have 2 there. Hmm. Okay, that works. Dang it. Hmm. Hmm. Can this actually... So if we have 4 here, that makes this 3 and 3. So this is guaranteed to be 3 adding up to 16. Guaranteed 3 adding up to 18. I guess that's possible. 18 then would have to be... Cannot contain a 3. It could be 4, 6, 8 or 5, 6, 7. So either way, 1 could not be here. That would force 1 to be here. No 3 here. So this would be the 4, the 5, and then you'd have 6 guaranteed here with 7 or 8. For 3 here... to add up to 16 without a 3. Can we have 2? 2, 6, 8 does work. There's no 3 involved in either. So that is possible. So what happens if this is 5? If this is 5, this becomes 1, 4 as a pair. That eliminates 4 there. So this becomes 3. This must be 5. So this must be, what? 1, 2, 3, 4, and 6. We'd have 7, 8 as a pair there. So this is 5. That makes us 2 and 3 to add up to 5. No 3 here. You can't... Well, you could have 4 digits adding up to 10, potentially. So that would be 4 this way. This would be 3. This is looking okay-ish. No, 1, 6. This would be 1, 5, 6. That doesn't seem as restrictive. This seems actually more like the answer. So what happens if this is 6? If we have 6 here, this is 4. No 7, 8 here. This is 3 here. That forces that to be 2. So this is 2. No 7, 8. No, it'd have to be 7, 8. No 1, 5, 6. This would be 4 here, and that would be 1, 5, 6. So that would leave 2, 3, 7, 8 as the remaining digits. This would be 4. It's part of this. So then this is not 4. It's really hard to see that. That's 2 or 3. 4 would eliminate 4 there. 2 would eliminate 2 here. So this is at least 3. This cannot be 5. 1, 2, 3, 4, 5, 6. Oh, it could be 5. As long as this is 3. Okay. So this looks okay also. This is 6. That's 1, 5 as a pair. That eliminates 5 in the rest of the region. This can't be 5 either. So this is 3 or 4. Actually, this seems less restrictive. Huh. One, 4, that's 3. This is 5. 7, 8 as a pair. 3, 4, 6. This is 7, 8 as a pair. No 7, 8 here. This would be 4. So that would force this to be 3, which means this can't be 3. This can't be 3. That's 4, 5. So this cannot be 4 here. If this is 4, that means this would have to be 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9 cells in the region. And that would be 2 or 3 as a pair. This would be 1, 5, or 6. This would be 3 going that way. This is definitely 5. This can't, it could be 2, 3, 7, 8. This can't be 7, 8. This can't be 3. So this is 1 through 6 here, 1 through 6, 1 through 6, 1 through 6, 1 through 6. That could still add up to 10. That's interesting. So then that would force this. So this would all be part of the green region. And this could be 2 counting that, 3 counting that, or 4 counting that. Oh, this can't be 5. It would be 4. So then this would be the full region here. Cannot be 1, 2, 3, 4. So this would be 2 or 3. So this can't add up to 10. It would add up to 20. So this must add up to 16, I guess. So no 4 here. 20 with 4 unique digits. So this would be 20. This would have to add up to 20 with 3 digits. So that would be 5, 7, and 8. And it has to be 5, 7, and 8 because 6, 7, 8 adds up to 21. If you try to, you would have to decrease the 5, but then increase the 7 or 8, which would lead to a duplicate or going outside the boundaries of digits. So the problem with that... Okay, so 5, 7, 8. That means the rest of this row would be 1, 2, 4, and 6. So that's possible. No more 4s here in the red region. So this would be guaranteed. Oops. We'd have boundary there. It cannot be a full 3 because then this would have to be 2 in that instance. So no 2 here. That means this can't be 2. That would be 3. So we have blue as a region there. Because if this were 3, again, we can't have all 6 of these be part of this region. Because that would be a 9-cell region when it's supposed to be 8 at most. And we can't form a full region that way. So then this must be part of this. Which means this is a different region. We have 1, 2, 3, 4. Well, we could have 5 there as long as it goes. This is part of yellow. And then this is part of red. So this is 3. Okay. This, in this case, then this has to be a 2. Because this is going to add up to... This is at most adding up to 10. This is at least adding up to 10. So then you'd have to have 2 and 8 here. There's no 8 here, no 8 here. This adds up, so this must be 10 in value. That's 10 in value. So then this has to be 3 and 7. So these are part of the same region. Well, this, I guess it could be part of that region. We can only have 3 more here as part of this region, and it can't form a full region by itself. So these have to be part of this region here. We have 3 and 7 here. This has to be 2. So we have 3 digits adding up to 16 with a 2 in it. So then this would have to be 2, 6, and 8. Okay, so no 2 or 6 here. This is 6 or 8. That leaves the remaining digits as 1, 4, 5. Two and 3 cannot be here. We have 2, 8, 3, 7. This is 8. I don't know. This is kind of looking like the solution. I don't know. 20. This adds up to 20. So 3 digits adding up to 16 there. Which means these 4 digits add up to 16. This is 8. This is a different region. This would be 3, 5, or 7. This... Hmm. None of these can have 5, 7, or 8. So we have 1, 2, 3, 4, 6. No 2 here because of 2 in the row. Can this be 3 digits adding up to 18? 4, 6, 8, or 5, 6, 7? The answer is no. So then this would have to be 4. So this is 4, which makes that 1 and 4. That would not make that 4. That would be 5. So then these would have to add up to, so we have no 4 here, no 4 here. We have 1, 2, 3, 4, 6 here, no 4 here, no 4 here. That leaves this not as 5, so it's 7 or 8, 7 or 8 there. So we have these digits are all 4, so it adds up to 18 here. This is 3, 5, or 7. So these 3 must add up to 17. You can't have 5 and 7 here, so 3 has to be one of these two. So then this would be boundary here. So 1, 3, and 5 is an odd sum. 1, 3, and 7 is an odd sum. And 6 and 8 is an even sum. That does not going to add up to an even sum there. So 1, 3, 5, and 6 adds up to 15. 1, 3, 5, and 8 adds up to 17. 1, 3, 6, and 7 adds up to 17. And 1, 3, 7, and 8 add up to 19. So this is going to fail. So therefore, this cannot add up to 5. That's the contradiction. That was pretty convoluted to get to there. I don't know. Not sure if I like that, but it is what it is. Okay. So then this adds up to 6. So this is 6. This becomes 4. That's 3. This is 6, so this must be 1 and 5 adding up together. That eliminates 5 in the rest of the column, or region, I should say, and column. So this can't be 5, it's 3 or 4. This is 3. This has to be 1, 5, 6 here. So this must not be 1, 5, or 6. So we've got boundaries here. This is medium. So we have 2, 3, 7, 8 remaining. This can't be 3, so this is 4. It's part of this region here then. So this cannot be 4. No 4 here. It's 3 or 5. 3 eliminates 3 here. It's 2. So this is 5. This can't be 5 even. So this has to be at least 6. And it can't be 18. It could be at most 10. So it's 6 to 10 as a value. So we're going to put this minimum here and the maximum here. So 6 to 10. Okay, we have 3 or 4 here. This is part of the same region. We have 2 or 3 here. So this is at minimum 6 still. It can't even be 6 though. That would be 2 and 4. So it could be 3, 2, 1. So it could still be 6, I guess. So minimum here is still 6. Maximum now is at most 3. So it'd be 3 plus 7 and 8, so it's at most 18. Okay. It's at most 10. So this has to be 4 through 8 here. This can't be 4 anymore. If it's 4, this would have to have a value of 10. But 4 digits aren't going to add up to 10. So this is 2 or 3 also. So this adds up to 16. 16. 6, so this is not 4. It's 3 or 5. So this cannot be 5 digits adding up to 16 there. We have 3 or 4, 3 or 4. Odd and even, that's going to be a differentiator only. Huh. No more 1 or 5 in the red region. So we have 2, 3, 4, 6, 7, 8. This can't be 2. So we have green, or red, blue here. Six to 18 here still. 6 to 10 here. So these two are part of the same region. I don't know why I randomly just gave a color there. So if this is 5, it has to be 20, right? Yeah, 5 unique digits can't add up to less than 15. If it's 3, then it's 10 here. This is at least 3 digits. So this has to be at minimum 6. It could be up to 4 digits, which means its maximum is quite big. 4, 6, 7, 8 is 25. Okay. We do know there is a boundary here. If this is 3, then that forces this to be 5. That's interesting. Is blue now the longest? 1, 2, 3, 4, 5, 6, 7, 8. So no 3 here. No 5 here. This has to be part of yellow because there's no other region it could be part of. You'd have boundary going that way. Here. This is part of a different region, so this must be orange. Oh, we also know boundary there. That's actually good. So we know this is boundary, but it could still be blue. 1, 2, 3, 4, 5, 6, 7, 8. Yep, could still be blue. Ugh. Okay, so we were trying. What happens if this is 3? Then that's 5. This has to be 3. No 3 there. This would be boundary. Orange would have to go out here because it can't be blue anymore. This would be orange. We have dark going there. Orange has to go there. So we have boundary there. These would both be blue. So these 5 would add up to 18. We don't have a 3 there. So the 3 would have to be one of these. So this would be 3, 7, 8. Because that's the only way that it could add up to. This would all be yellow. And this would have to be what? 1, 2, 4, and 6. Which would make this a 7, 8 pair here. Okay. This adds up to 16 in that case. So far, this is working fine. This adds up to 16. We have 3 and 4 here. 16 minus 7 is 9. So we could have 1, 2, or 7 there. So this one of these is 7, 8. One of these is 7, 8. That eliminates 7, 8 in the rest of the column. So it's 1, 2, and 6 here. So far, this looks fine. Dang it. I was hoping this would lead to a contradiction. But so far, it's fine. This would be at minimum of 11. So it would guarantee these are part of the same region. That doesn't really restrict us. I was hoping that would lead to a contradiction. Obviously it didn't, so let's not continue down that route right now. Boy. What else do we have? What happens if this is 3? So we have 3 here, that's 4 there. So, oh, I don't think that can work. We have 1, 2, 3, 4, 5, 6, 7. And only one out of these two can be part of blue. Obviously can't form a full region, and this cannot be part of dark because of the rules where this must be a different region there. So this cannot be 3 here, which means this is guaranteed to be 5. And I think that's the full set there. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So that does... So this is the full set here, which does actually force this to be 3. I was saying that this looks too tidy to basically be not part of the solution. So this is... Then 3 can't be here. 3 must be part of this set here to add up to 18, because 18 plus 18 adds up to 36, which is the sum of the digits from 1 through 8. That means these must be part of yellow. So this is 5. We tried that with 3. It doesn't work because it blocks this again. So this must be orange. And so all of this is still kosher. Orange still has to go out that way. We don't know if this is 3 or 2, though, because we were trying to make an assumption there. So this is 3, at least, and this must be 1, 2, 4, and 6. That makes this 7 or 8. 7 or 8. This is then at minimum cannot be 6. It's at minimum 11. Can be at most then 3, 6, and 8, which is 14 plus 3, it's 17. So this is 11 through 17, which means this is guaranteed to be part of that region. So therefore that's part of that region. It could be 2 digits. That's fine. It cannot be 1 digit because 1 digit can only be sum up to at most 8. Okay. We don't know what this is. So these 3 add up to 12. Can we have it without a 7 or 8? And without 4? 1, 5, and 6 works, but this can't be 1, 5, or 6. So I think we have to have a 7 or 8 here. And this is 7 or 8, which eliminates 7 and 8 in the rest of the column. So this has to be 1, 2, 3, or 6 here. One of these is a 3, so this adds up to at least 9. So this is at least 9, and this is at most 10. Can it be 3? It can be 3 if this is 4 with 1 and 5. That is possible. We have a 7, 8 pair in column 3, which eliminates 7 and 8 in the rest of the column, so we're left with 1, 4, 5, and 6. Interesting. We have 5 yellow. We can go 6, 7, 8. Maybe can't go 8. So we have 5 yellow. 3 of them are here then. They cannot be part of this region. We have another 3 somewhere. So it's 9 or 10. This adds up to 10 or 20. We're not sure. Can it be 5 then? So we have all green. That would force this to be 5. This would add up to 20. This would have to add up to 36 minus 20, which is 16. So possibly. That would mean this adds up to 20, but it could still be 3 or 4. Pretty convoluted. This can't be 4 anymore in that instance. That seems fine. Okay. What about the rest of row 8? We have 1, 4, 5, 6, 7, 8. No 4 here because of 4 in the column. If this is 2, then this must be 2 digits adding up to 9 or 10. So it'd be 3, 7, 4, 6, or 3, 6, 4, 5. If this is 3 here, that forces this to be 4. And these 3 digits must add up to 9 or 10. Cannot be 4, 1, 4 or 4, 2, 3. For 3, it'd be 3 digits because of 3 already in the column. So it'd have to be 4, 1, and 5. So this is either 3, 6, 3, 7, 4, 5, or 4, 6, or this is 4 with 1 and 5 here. Okay. I don't know how helpful that is, but okay. Huh. If we have, so say we had 5 here. Then this cannot be part of green because there's too many cells here. I guess you could have 3 here. That could potentially be still green. We have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Does that work? Maybe. 16. So we tried it without 7 or 8. That's not going to work. Because this can't be size 4, it cannot be 5. That's too, that would block this off from forming regions. So it's 2 or 3 here. So we can't have 4, 1, 5, 6 here. So we need to have a 7 or 8 be part of it. Right, we can't have 4, 6, 2, 3. It's too small. But 6, 5, and 1. So therefore, this is 7 and 8 guaranteed here. What are the possibilities? Add up to 12 with 8 is 1, 3, 8. Add up to 12 with 7 would be 2, 3, 7. It cannot be another 1, 4, and 7 because we have a 4 there. So this is 1, 2. It could be 1, cannot be 8 because there's no other place for the 8, or it's 2, 3, or 7 here. So 3 cannot be either of these. So this is either 1, 3, 8 or 2, 3, 7 here, which forces 3 to be here. 3 eliminates 3 from being here. So this cannot be 3. Hmm. Shoot. I should not do that with that assumption yet. But this makes sense. 1, 2, 3, or 7. And one of these is 3, which means this can't be 3 here. This can't be 3 either. Yeah, so we're trying to make this assumption of 5. One, 2, 3, 4, 5, 6, 7, 8. So we could have yellow there. This cannot be part of orange. And it can't be its own separate region. Can we have enough here? So this would be 1, 2, 3, 4, 5, 6, 7, 8. So we could have orange there, and then this could be green. That is possible. No 5 here. This is 6, so this can't be 6 there. This adds up to 20, so this adds up to 16. So either way, this is going to have to exit out as a region. And this would then be 2 either way. Because it horizontally or vertically, it counts 2. Technically, this counts both directions, but it doesn't have to. I don't think it's a restriction, right? Oh, but this. So orange could only get to here. I guess this could be yellow, right? You could have yellow going that way and green going down to here, but that's the most you could have. So then this would be 1 or 3. I guess that's possible. This 7, 8 could not be any of these cells here, so it has to be here for the orange. This adds up to 20. So this must add up to 16. This digit is the same as that. This would see 1 or 5. So that seems okay. Huh. This 7, 8 has to be one of these two. That isn't helpful. This is convoluted. This is why it's very hard. Um, so for 18, so this could be technically, it could be sit down to 6. So this could even be 1. So this is 1 through 5 here. That's not helpful right now, but let's do it without the assumption here. No 3 there, so this is 1 through 5. 11 to 17. So it has to have at least 2. 17 could be 5. It's not going to be 5. If it's 5, these are part of the same region. That's too large of a region. So this is 2 through 4 there. Okay. What about 3? 5 just seems like the more restrictive one, and it is, but it still didn't seem to lead to a contradiction. Let's just continue, actually. Let's see if we can do something with this. No 5 there. Orange can only get to here. 1, 2, 3, 4, 5, 6, 7, 8. We have 3 more that could be yellow, 3 more that could be green. Yellow has to get to here because green can't reach there. This is 2 either way, which would mean this can't be 2. So we have red going that way. This cannot be 2, cannot be orange. It's 2 if it goes that way. It's 2 if it goes... I guess this could technically be green. Oh. So either way, this is 1 or 3. So we have green and yellow as some combination here. So we're not even limited that way. But these are limited by a certain amount. Seems okay. Again, this 7, 8 has to be here. There's no 5 adding up to 16. What are the combinations? 1, 7, 8. 2, 6, 8. So 2, 6, 2, 6, 8. 3, 5, 8. Can't be 3 here, can't be 3 here. So no 3, 5, 8. What about 7? No 1 with 7, because that would require 1, 7, 8. No 2 with 7. So 3 doesn't work. So 3 has to be here in the green region. Four, 5, and 7. Well, this is 1, 2, or 6 here. So 7 can't be 7 and 6 with 3, but we can't have a 3 in either cell. So those are the possibilities then. It's 1, 7, 8 or 2, 6, 8 here. So either way, 8 has to be one of these 2. That means no 8 here. No 8 here. This is pretty convoluted. Okay. Yeah, this is looking like more and more the solution. So let's not go down that path. Let's now assume this is 3. Then this adds up to 10 with 3, because you can't add up to 20. So it'd be 316 or 325. These three would add up to 10. So it cannot be 4 digits adding up to 10 because the 4 would be there. So this is also 3. That makes that 4. These 4 add up to 10. These 3 add up, sorry, these 4 add up to 16. These 3 add up to 10. So we'd have 3 there. We'd have 1, 6, 2, 5 as possibilities. If this is 1/6, this has to be 2. So the remaining digits in this row cannot be 2. So we'd have 1, 4, 5, 7, 8. I guess we could have 6 also. This adds up to 10 with 3 digits. No 3. It could be 1, 2, 7 or 1, 4, 5. So we're guaranteed a 1 there. Huh. Let's see, the problem is that doesn't seem that restrictive, so that's kind of why I didn't want to do that. It does make that this can't be 3. So that must be 3 there. Therefore, this can't be 3. So I don't think this can ever be 3 here, then. Yeah, it can't be 3. Can it be 4 is kind of the question I'm asking. Otherwise, it has to always be 2. So if this is 4, that means it sees 4 that way. Then this is boundary. This can't be 5 because then this doesn't have a region. So these are part of that region. So we have green. Otherwise, this is 3. So then this is full as a region. And that's because that's 8. 1, 2, 3, 4, 5, 6, 7. We have 5 cells here. So this can never be 4. It's always 2. We tried 3. 3 would force too many cells here to be part of the same region. So this is guaranteed to be 2. Interesting. But we don't know if it counts horizontally or vertically. Right. Yeah, this is 5 cells trying to be part of a region. Can't be a full 4 region by itself, but only 3 of them can be part of yellow, none of them can be part of green, and it can't orthogonally connect to the rest of the cells. So this can never be 4 for that reason. It can't be 3 because it would have to go that way, and then this would have to be 5, but then these aren't part of a region. Both of them would have to be part of the green, and that's too large. So this is 2. So that's a long, convoluted way of proving that this is 2. Hmm. Uh, This is pretty convoluted. From 1 to 8 each as once as well. Mm-hmm. Uh, hmm. Um, Again, 6 has to be one of these 2 digits. So we know 3 out of these 6 are yellow. Because yellow can't go here, it can't be connected to this region. So 3 are non-yellow. So they could be part of a full other region, which is not green. That would mean we have 3 reds here. And then 4, 5. I mean, that seems feasible. The problem is that the 5 looked like it worked pretty well. Okay, blah blah blah. 1 8. We must divide 8 exactly 8 orthogonally connected regions. 2 digits with different oddity parity, 4 with gray square in the same relative position. 1 counts how many cells it sees horizontally. So it sees vertically where region borders. Both cases. Contain the same values. Okay. Hmm. 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 That didn't seem to remove any possibilities. Hmm. I guess we try this way. If this is 4, that makes that 5. This is 4 going that way. That means this is 3 going that way. So no 3 or 5 there. No 4 here. 3 digits adding up to 18. With cannot be 1, it must be 5. That makes that 1. So it's 5, 6, and 7 adding up to 18. That means remaining digits in this region, we have to have a 4. 4 can't be here. 4 can't be any of these. So this is 4 here. So we're guaranteed an 8 here without 1. Oh, well, there we go. So this can't be 4. It has to be 3. Interesting. Well, that's kind of helpful, I guess. So no 4, this is 3. That means this can't be 3, it's 2. Okay. So these 2 are part of the same region. We have boundary here. These 3 are part of the same region. We have boundary here. So no 2. This has to be 2, 6, and 8. So we just proved because of this 4 that this doesn't work because this adds up to 6. That's the reason why. Okay. 3 digits adding up to 16 with a 2 here. It's 2, 6, and 8. So this is 6 and 8. That eliminates 2, 6, and 8 in the rest of the region. That eliminates 2, 6, and 8 in the rest of the column. So these 2 must add up to either 9 or 10. Cannot add up to 9. That would be 3 and 6. So it must be adding up to 10. So this is not 9. It's 10. Which leaves that as an 8 there. That eliminates 8 in the rest of the row and region. So this can't be 8 here. 8 also eliminates 8 here. So this is 7 to add up to 16. It's 3, 6, and 7. That eliminates 6 in the rest of the column and row here. So we have 3, 7 here. That leaves 1, 4, 5 remaining in the rest of the column. Can this be 3 adding up to 18 here? 5, 7, and 6. Yes, it could be. 2 does eliminate 2 here. So this could still be 3. It could be 5, 6, 7 with 3 there. Can it add up to with 4 digits? 5 without a 1 or 2 available cannot. It could be 3, 4, 5, 6. So it could. No, but then this would be 4. So without a 4 also. Interesting. So can we have 4? 1 and 3. It would have to be 1, 3, 6, 8. But one of the 6 or 8's not going to be there because one has to be there. 1, 5, but I can't have both 1, 5's here. So if we have 1, that's not going to work. It can't be 1, 3, 6, 8. If we have 5 here, without 4, no 1, it would have to be 5, 3, 7. So, okay, if we have 4 here, that means this must be a 3, 7 pair. 3, 7 adds up to 10. So these 2 would have to add up to 18. 8, which is 18 minus 10. So the answer is no. That's not going to work. So 4 cannot be here. It has to be 3. Interesting. Right? If we try to have 4, that means these 4 are all part of the same region. 4 would have to be here. This would be 3, 7, 3, 7 left in this region. That's 10. But 1, 6, and 1, 8 add up to 7 and 9, not 8. And 5, 6 adds up to 11, which is too large. So this cannot be 4. It's 3 also this way. That's interesting. And this must be 5, 6, and 7 to add up to 18 for 3 digits. So 5, 6, and 7. No 7 here. This can't be 5. It's 1. So 6 eliminates 6 here, so that's 8. No 8 here. I don't know why I colored that a different whatever. We have boundaries. So this could still be part of it, and it would see 3 vertically. Remaining digits of row 7 here are 1, 2, 4, 8. That's possibilities. We have a 3, 4 pair in row 8 here, so that leaves 5, 6, 7, 8 as the remaining digits. We need a 3 or a 4 to be part of this red region, so this can't be here. So either this is part of it or this is part of it. So one of these is the other 3, 4. We don't know which, though. If it goes here, it must be 3, but it could extend here. So that's fine. So we have 10 and 10. 3 eliminates 3 in the rest of the column. 2, 6, and 8 add up to 16. 3 and 7 add up to 10. 2 and 8 add up to 10. 3, 6, 7 adds up to 16. 7 in row 5 has to be one of these 5. That's not too helpful. Seven eliminates 7 here. So this is 8. That eliminates 8 in the rest of the row. 8 also eliminates 8 there. Pretty convoluted still. 3 digits. It's adding up to 16. We don't have 1, 7, 8 anymore. Okay, so if this is 5 now, that's interesting. So if this is 5, that means we need 1, 2, 4, 3, 4, 6 here. This can't be 7, so that would force this to be 8. We'd have 7 there. This would have to be 6, so we'd have 1, 2, 4 here. So far that seems fine. If it's 3 digits adding up to 8, 16, it would be 2 and 6 here. It could not be 4 digits adding up to 8, or 4 digits adding up to 16, because if we had 4 digits adding up to 16, 8 plus 1, 2... You can't have 1, 3, 4 anymore, so because of the 4 in the row. So it'd have to be 1, 2, 5, but then we already have a 5 in the region. So this would then have to be 3 here, which would force this to be 4 here, which is not going to add up to 10. So then this must add up to 20. So that forces this to be a 5. So that seems okay. So this is all the same region. This is, oh, that's going to be interesting. 4 eliminates 4 here. 4 digits must add up to 20. Cannot add up to 10. That's not going to work because that would force 5, 7, and 8 to be here. And that already adds up to 20 by itself, plus 1 would add up to 21, which doesn't work. So therefore, this cannot be 5 here. There we go. So then this must be 4 digits to add up to 16. That means that's a boundary. 4 digits, which includes a 3. So these adds up to 16. These 4 add up to 20. Doesn't it have to be 5, 7, 8 to add up? Oh, no, it has a 4 also in it. So the remaining 3 must add up to 16. So these 3 add up to 13. Right? We tried 5, it doesn't work because of the combination, how that works. That was interesting. Pretty convoluted, though, but interesting. So these 3 add up to 16, because these 4 add up to 16. 36 minus 16 is 20, minus 4 is 16. 16, you could have 1, 7, 8. So if this were 1, this would be 7, and that would be 8. 16, 2 would be with 6 and 8, so you could have 6, 8 as a pair here. 5. So 16 minus 5 is 11. No 4, 7, no 5, 6, so it'd be 2, there's no 2, 9, it'd be 3, 8. So either way, you have to have an 8 here, right? 1, 7, 8, 2, 6, 8, or 5, 3, 8 here. So this cannot contain an 8. So we have to have 1, 2... Oh, it can't be 5, 3, 8 because of 3 in the column. So this is then 1 or 2. Interesting. No 3, we have a guaranteed 8 here. So the remaining digits, it's either 178, 268 here. So we have 1 or 2, we have 5, 6, 7 as possibilities for the rest of the column. Okay. This is 1 or 2. So this is at most 15. It cannot be 18. It'd be at most 15. That's not too helpful. We do know we have a 6 or an 8 there. That is interesting. Oh, 8's going to have this. No, 8 could be. So if this is 8, this has to be 3 digits adding up to 16. Because if you have 4 digits, now you do have a 5 available now. Okay. What happens if we set this to 3? If this is 3, this is 4. No 4 here. This must add up to 20 at least. Sorry, have to add up to 20, period. So this would add up to 20. It obviously can't be 3, so that would force this to be 5. We'd have that combination then. No 5 here. This has to be orange going that way. This must be yellow here. And this is yellow-green as a pair. This would be some other region, so we'll make that red. So if that's 3, this is 4. These 4 must add up to 20. These 4 must add up to 16. Does that... That doesn't... Oh, it does work. Never mind. Okay, I was thinking that doesn't work, but, you know, it's still possible. Huh. 1, 2, 3, 4, 5, 6, 7. You could have one more here. Then we'd have 1, 2, 3, 4, 5, 6, 7, 8. So we'd have to have 3 exit out. So then this would have to be part of that if that were the case. And this would be 3. Right. So if this is 4, there's only one 4 space here. We can only have one region go out, so we have to have a full region here. So we'll do just this as the full region for now, just to symbolize that. We can only go 1 to be part of blue, therefore this can't be red, so red would have to be here, and it would have to be 3. So that would force that to be 4, that would be 3, that... Oh, wait. We also knew that anyways, so let's not do that yet. So this is at least 3, which means we have to go 3 that way. Interesting. Let's still continue. 3, 4. That means blue goes to here. We can only have 8 here. So there must be something going out. And therefore this would be red, which would force this to be 3, which would make that 4. That's 3. So then this would be boundary. Now that's interesting. What happens if we have something like... So what happens if we have 4 here? If this is 4... Oh, that's not going to work. Well, there you go. Then these become all dark. These must be part of a region, but can't be part of blue, so they must be part of dark, and we have 9 cells in that region. So this is not going to be able to be 4. It's 3. So this is 4, which eliminates 4 here. That means we need a 3 in one of these 2 cells. So one of these 2 cells is 3 for the red region. Still could be 17 for 3 digits. This is not part of this region because blue already has a 3 available. So we're going to make that part of yellow. What happens if we go red that way? Then, again, we have only one boundary that can go that way, so it has to do something like this. So we'll set that right now. Well, we know one of these is an 8, and one of these 4 is an 8. So there's 2 regions guaranteed in these sets. One of them has to go out, so this is 3. Let's just signify it for now. We can only have 2 more blues, so we're going to have something coming out that way. Let's make it pink, I guess. So then this would have to be 3 in that instance. Which would make this 4. Let's not do that yet. We know this is guaranteed to be 3. We know there's a boundary. We tried making that red. So this would be 3. Obviously no 3 there. You have a full region here. You have another region going up. This would be 3 in size. That would make that 4. So you'd have dark there. This adds up to 16. We don't know what this adds up to. So we know 5 has to be one of these 3 digits. 4, yeah, 3 digits here. Because this can't be 5 there. We kind of already knew that, though. So we know, again, one of these is 5. Pretty convoluted. Right, so we're trying to... What happens if we make this red? Okay. So we'd have 3 here. This would not be 3. We'd have to have a yellow going here. Some pink region going here. Yellow could be part of these. So could blue. This is 3. This is 4. part of that region. These two would add up to, so we have 16 here. 36 minus 16 is 20. 20 minus 11 is 9. No 4, 5 available, no 2, 7 available, so this would be 3, 6, or 1, 8. So 6 here, or 3, or 1, 8 as a pair. Okay. This is 3. Could be 20 or 10 here. If it's 20, it's 5, 7, 8. If it's 10, it's 1, 2, 7, or 1... 1, 4, 5. 1, 2, 7, or 1, 4, 5. So this is 6 or 8, and this is 6 or 8, which means none of these can be 6 or 8. So we have guaranteed 5 here. And 2 here with a 1 or 3. So 5 and 2 would both have to be here. No 3 here. We have 1, 2, 3, 4, 5, 6, 7. So we can only have one more dark, and this can't be blue. So this must be part of another region. It could be part of pink. Or it could be some orange one. It has to get out, though. So orange has to get out. Therefore, these must both be blue. Or we have 2 blues somewhere here. So we have 2 blues and yellow in some direction here. Because blue cannot go out any further, because orange has to get out somehow. Could be part of this. Therefore, one of these is an 8. That must be part of blue. Pink can't go any further down here. We have a yellow containing an 8, and then blue must have an 8. Could even be blue, blue that way, and this be yellow, yellow. So one of these is 8, which means this can't be 8. This cannot contain an 8 here, so if this is 3, it's only 10. Interesting. So then this would have to be 3 in that case. You again would have it would be 1, 6 or 2, 5. And it cannot be 2, 5. So this would be 3, 6, and 1. Well, that's interesting in itself, too. That means no 1 or 6 here. It's 2. That makes the 6 there. This can't be 2. It's 3. So you would have to have 3 going that way. This adds 2, 5, 6. So 1, 3. Okay. These add up. So 9 again. 7. 16 minus 7 is 9. So this must be 1 and 8. So we have 1 and 8 here. No 8 here. This would be 2. We'd have 4, 5, 7, 8 remaining. So this is done here. No 6 here. This is looking kind of fine also. You cannot have it add up to 6. In fact, this is at minimum 10. So then this would have to be a 2 here. That means no more 2 in the column. So this is 1, 5, 6, 7. This adds up to 10. We need a 1 here somewhere. So 1 has to be specifically here. So this adds up to 16. It cannot be 7. It's 1, 3, 5, 7 here. So no 7 here. So this must be 1, 4, 5 to add up to 10. And we have a contradiction. There we go. That's pretty long convoluted. Yeah, it would require 5 and 7 to be here, which is not allowed. Because then this would add up to 10, but that's only because this can only be 10. Because we don't have 8 available here. 8 has to be part of the blue, which means 8 cannot be here. Huh. Pretty convoluted way of proving that, but okay. I'll take it, I guess. But that doesn't tell us too much, does it? Actually, I guess it kind of does, maybe. It just means this can't be 3, so we know that's a boundary. So this has to be the 3. And that is counting the number of digits going down. So this is 3. Remaining digits in column 2. We have 1, 2, 5, 6, and 8. Obviously no 2 here because of 2 in the row, and then everything else is fine. This is counting vertically. So this must count horizontally. So it's up to 6. 1, 3, 4, 5, 6. Because of no 2 in the column. So the problem is that proof does not preclude having 2 regions exiting now. Which could take both 8s, which unfortunately then doesn't resolve too much. Remaining digits of row 1 are 1, 5, 6, 7, 8. Okay. So this is counting horizontal. Can we really have 6? I think the answer is no. We could. 1, 2, 3, 4, 5, 6, 7. And then we have 1 more going up. Then that can't be 3. That can't be 5. It would be 3. Oh, interesting. Okay. If this is if this adds up to 10, then this has to be 1, 2, 7 here. Huh. That would mean no 1, 2, 7 here, so it'd be 5 and 6. Okay, so yeah, what happens if this is 3? If this is 3, this can only be 3 in size to add up to 10 here. You can't have 1, 4, 5 available anymore because that would eliminate all possibilities for that cell. So it'd be 1, 2, 7 here, which would eliminate 1, 2, 7 in the rest of the region. So this can't be 7, it's 5, 6 as a pair. That eliminates 5 and 6 in the rest of the column. So we have 3, 5, and 6 here. What does that add up to? It's 14. 14 plus 2 adds up to 16. That would force this to be 1. You'd have 7 and 8. 3 here would force this to be 4 there. But you could have 1, 2, and 5 there. So this would be 1 and 7. That means there's no 1 or 2 here. We have 4, 5, 6, 8 as possibilities. This would have to be 4 digits and 1, 2, and 5, which is fine. That would force this to be 6. That would force this to be 3. So no 6 there. So far that's okay. This would be 1. So this would be value 6, 7, or 8 in that instance. So you would have to have a boundary there. Interesting. Can you have 3, 2, 1 here? The answer is no. Three, 2, and 1 would force this to be 7 and this to be 8, and that's way too big to add up to 16. We need a 1 or 2 here. So three digits can never add up to 6. 3 digits can never add up to 7 because that would require 1, 2, and 4. And 3 digits can never add up to 8 because that would be 1, 2, and 5. Can't be 1, 3, or 4 because of 4 in the column or in the region already. So then this has to be 2 in that instance. That means this is not 2 here. This is 1, 6 as a pair. 2 and 4 add up to 6, which leaves 3, 7 remaining. So then this is 2, no 3. So it can't be 2, 4 adding up to 6. Could be 2, 5 adding up to 7 or 2, 6 adding up to 8. So this is 7. This adds up to 7 or 8. 2 is here. This is 3, 7 as a pair. That forces this to be 8, which means this can't be 8. That's 7. This cannot be 3, 1, 6 adding up to 10. So this would have to be 3, 2, and 5. And we have a contradiction. So there we go. That was really convoluted. Can't be 3, 1, 6 because that would eliminate all possibilities for that cell. So this cannot be 3 adding up to 10. That's the contradiction. That's a long, convoluted way of doing that. Anyways. So this must be 5. Okay, well, that tells us a lot, because then we have these digits can't form a full region by itself, because we have to have 3 be part of the yellow region, which leaves us only 7 cells left. So that means this must be orange that way, and this has to be yellow, because if we try to make it green, the yellow can't connect. You can't get, the only way you can get green is 3 green that way, and then yellow doesn't form a full region. So this is yellow, and this is some combination of yellow and green. And this adds up to 20. So this 7, 8 means none of these can be 7, 8. So this must be 7 or 8 here. So this is 5, and again, we have this blocked out. So red does have to go this way. This is vertical here, so this must be horizontal. It can't be orange, so this is 2 at most. It can't be 2, so this is 1. So this is, it can't be 2 greens. If this is green, it would have to be green here, because you can't go 3 greens down. And you can't go green, green here, because that would block that from a region. So this can't be green, it's yellow. That means it must orthogonally connect to the yellow, so this is yellow there. So no 1 there. We need a 3 for the yellow region, so it has to be there. That makes this not 3, it's 7. This can't be 5 or 7 because this is 5. These are not yellow, this is green. Okay. So then this is done as a region. No more ones in the yellow region. This is 4, 5, 6, 7 as a quadruplet, which eliminates 4, 5, 6, 7 in the rest of the row. So this can't be 7. This is 8. This can't be 8 at 7. That forces this to be 7 there. This can't be 6 or 8. It's 1. No 1 here. It's 4. This adds up to 20 without a 1. Minimum then would be 2, 3, 4, 5, 6, which adds up to exactly 20. So this must be 8 here. No 1 or 4 here. It's 5. No 4 or 5 here. It's 1. This can't count vertical because that would be only 1, so it must count horizontal, so that's 4. No more 1 here. 8 eliminates 8 in the rest of the column. We're guaranteed a 7 here. We are guaranteed a 3 here. 3, 4, and 7 adds up to 14 plus 2 is 16. So this must be 2, 3, and 7. No 1. 7 eliminates 7 here, so that's 3, which makes this 2. That means this can't be 2 or 3. It's 7. No 2 here, so that's 6, which makes this 1. So this is 20, therefore this must be adding up to 16, so that's 1, 8, and 6. 2 can't be here, 3 can't be here, this can't be 4, 5, so that's 6. 1 eliminates 1 here, so it's 5 and 1. This must be 2, 3 as a pair. 4 eliminates 4 there and 4 there. No 5 or 6 here because of 5 or 6 in the column. That leaves just 4 and 7. This can't be C all 8. It could be potentially 6, but very unlikely. We have 2, 3 remaining in the orange row, in the orange region. This is 2, so this is part of that region. 2, and again, well, we don't know if this is 2 or not. So this could be 6 at minimum and 10 at most. This has to be at least 4. 4, 5, 6, 7, 8. No 7 or 8 possible here because of 7 or 8 in the column. So this is 6 to 8 here. So this can't even be 10. It has to be 8 at most. This is 3 and 7. So it still could be 11, but now the maximum could be only 16. 3 digits here. That's boundary. This adds up to 20. Either way. 1 eliminates 1 here. 7 eliminates 7 here. 8 eliminates 8 here, so that's 2. That means this can't be 2 here. It's 3, 8 as a pair. 2 eliminates 2 here. 7 eliminates 7 there. Remaining digits in column 1, we have 3 and 6. 3 eliminates 3 in the rest of the row, so this is 6. That's 3. Red can only have 4, 5, 7, or 8 left. Also, we have a 2, 3 pair in column 4, which eliminates 2 and 3 in the rest of the column. No 1 here because of 1 in the column. So remaining digits are 4 through 8. No 6, 7 here because of 6, 7 in the row. Remaining digits of row 3, 1, 4, 5, and 8. No 8 here because of 8 in the column. No 4 here because of 4 in the column. So this counts horizontal. This counts horizontal. This counts vertical, so this must count vertical. This can count either. 7 eliminates 7 here and here. Remaining digits of row 4. We have 4, 5, 6, 7, 8. No 4 here, no 7 here. Okay, so this is 20. That's really hard to read, but whatever. This is 10. This can't be part of that region because it already has a 2. We already have a 4 in the dark region, so this can't be 4. It's 2, 5 or 2, 6. So this is 7 at minimum and 8 at max. But the problem is this could still be 2 cells, and you could have 1, 6 there, or 1, 7, or 2, 6 there. So that's not too helpful. Okay, so what's done? This is done. 2 and 4 add up to 6. 4, 5, 1, 6, and 1 add up to 16. 3, 6, and 7 add up to 16. 4, 7, 3, 2 adds up to 16. 2 and 5 and 2 and 6 we don't know. 5, this is essentially done. 5, 1, 2, 4, 6 adds up to 18. We don't know what that is. 2 and 8 add up to 10. 5, 6, 4, 3, 2 adds up to 20. So we just have this one and this one to solve. 2 digits add up to 6, 1 and 5. 2 digits add up to 10, 3 and 7. 3 digits add up to 16, 2, 6, and 8. 3 digits here, we don't know what it adds up to. 3 digits add up to 18 here, so that's done. We don't know what that is. We don't know if it's 3 or 4 here. We don't know if that's 3 or 4 there. Ugh, okay. Let's mark A and B, actually. Is that going to be helpful? I don't know. I don't think so, actually. Let's not do that right now. Um, 3 digits adding up to 16. No 178 available. It could be 268. No 3 or 7 available. Hmm. Remaining digits of row 6. 1, 2, 4, 5, 6, 7. Dark needs access to an 8. One of these 3 is going to be 8 here. So dark needs access to an 8. It could be 1, 2, 3. It cannot be, it could be 1, 2, 3. It could be 1, 2, 3. Cannot be 1, 2, 3 there. So it could be 1, 2, 3 there. It could be 1, 2, 3 that way. Can it ever be 1, 2, 3 there? Can't be 1, 2, 3 there. Could always have been that again. So this would be 8 if that's the case. So axis is 8 there, or axis is 8 here, because it can't be 3. Can it go this way? It can't go this way. You can't go to the 2. You can't go 3 that way because we don't have an 8. So can't go this. Could go that. Can't include that. So then it could be, can it be 3 that way, 3 that, it can't be 3 this way. So it could be 3 this way, 3 this way. Can it go 3 that way? We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. No, cannot go 3 this way. So it's either 3 this way or 3 this way, which means this is dark, which means this has to be an 8. Because it can't be 3 because of 3 in the box, so that makes that 3, which means this can't be 3, that's 2, which makes this 3, which makes that 2, which makes that 3. No 2 here. Where's 2 in row 7? It has to be there. 8 eliminates 8 in the rest of the column. We have 2 8s here. One of them's part of red, the other's part of the other region. So we're going to mark this as pink. This is pink. So we have boundary here and boundary here. So it goes either one. So this is darker pink. So we have 2 more reds. So 2 reds could go there. Could go here. Dark can go either of these 2 or either of these 2. Pink could obviously has to go there or there or any of these, technically. Hmm. 2, 3, 4, 5, 6, 7. Okay. I think this has to be pink. If it's red here, pink cannot go all the way around here. So this would have to be dark, which makes this pink. Yeah. So if this is dark, that forces pink to be all of these, and then it has to be pink there. If this is pink, it has to orthogonally connect, but this would be dark here, so then it would have to connect here. So this is pink, no matter what. So we have 1, 2, 3, 4, 5, 6. You could go 7, but that would have to be 8 there, and therefore this is always red. So that's always red. So no 6 here. So this has to be pink. What else do we have? 5 and 6. If these are both pink, it's 1, 5 as a pair. That's interesting. That would force that to be 8, and we'd have 4 there. Definitely very hard. Even this aspect is still pretty difficult. Hmm. Okay. So this is vertical, which means this... No, sorry. This is vertical, which means this is horizontal. This is horizontal, which means this is vertical. Hmm. 5, 6, 7. Hmm. Okay, what happens if this is 3? If this is 3, then this must be 5, 7, 8, adding up to 3, or 20. So we'd have 5, 7, 8 here, which eliminates 5, 7, 8 in the rest of the column. This can't, or the rest of the region. This can't be 5 or 7. It's 6. So no 6 there, no 6 there. This adds up to 9, so these two must add up to 7. 9 plus 7 is 16. So therefore this would be 2. This would be 5. That would be 1. No 5 here. This is again would be 4. So this would be 4 here. Dark as a region. This would not be 6, so this would be 8. That would be 7. So this has to be 1, 2, and 5 here, which does work. That eliminates 1, 2, and 5 in the rest of the region. This can't be 8 because of 8 in the row, or an 8 in the region. Therefore, this is 3, 6, or 7 there. No 7 here. 3 eliminates 3 here, so this is 6. That's 7. Cannot be 5 here. Okay, so we have 13 here. Then this adds up to either 14 or 15. This would have to only add up to 14. So then this would be 4. You'd have 6 here, that's 1. So no 1 there. No 4 here. No 6 here. No 6 there. This would have to be 1, 2, and 7. 1, 6, and 7 adding up to 14. 3, 4, and 7 adding up to 14. So no 1 here. It's 2 and 5. This must be 6, and that would be 3. So one thing we know is these two digits, one of these two digits is a 3. So that's kind of helpful, I guess. Okay. So we know there's a 3 either here or here. We're not sure which. That means 3 cannot be in the rest of the row. 3 digits adding up to 16. I don't know. Maybe it could have reached a contradiction there. Hard to say. What about 3 digits? That makes that 4. So then this is blue. That's boundary. No 4 here. No 3 here, obviously. We have boundary here. 3 digits adding up to 16 without 3, 4, or 7. So I think it has to be 268. Is that right? So 268 That eliminates 2, 6, 8 in the rest of the row. So we have 1, 4, 5, 1, 4, 5. That eliminates 2, 6, 8 in the rest of the region. No 2, 6, or 8 here. No 3. Oh, that's interesting. So if this is 4, we still need access to a 3. So if this is 4, this has to be a different region and must go out. If this is 3, we still need access to a 3 somewhere in the dark region, so these both can't be dark. So at least one of these, again, is a different region, and it must go out. So either way, it must go out. So either way, this is guaranteed to be a different region, and it must go out. It must continue on that way. So these are blocked from being another region. We are guaranteed this must, if it's 4 digits adding up to 16, it has to be 1, 2, 5, and 8. With that, because can we have non-8 as the largest digit? So 1, 2, 3, 5 is too small. What about 2, 3, 5? It could be 2, 3, 5, 6. Oh. So that's actually not necessarily true. Okay, let's go back then. Oh, no, because if this is 4, that forces this to be 3. And this must be 5, 7, 8, adding up to 20. That eliminates 5, 7 there, so it's 6, which does force that to be 8. And so we need an 8 there. So this is always going to have 2 or 8 here. Because it's 1, 2, 5, 8, or it's 2, 6, 8 here. So no 2 or 8 here. One of these is a 3. And 3 is not going to be part of here. It's not going to be part of here. So we need to access the 3 somewhere. So if it's 4 here, the 3 can only be accessed by one of these two. So one of these would be the 3 for the dark. If we have 3 here, we could potentially access 3 going that way twice. You can't go this way. Right, this still cannot be 2 darks here. So that means this does have orange going out. Okay, so there's that. So we have orange going out that way. And we know dark has to go here. That's not true, I guess. Well, okay, so dark is going to be one of these two. So orange cannot go this way than there. So this cannot be some other... It has to go... It can't go here, then here. It can't exit out here. It has to go here, no matter what. So this is orange. 3 again is one of those two. 8 is one of those two. 8 is one of... Oh, 8 has to be one of these two. But that's not helpful. We know our red already has an 8. So this is 2 and 8. That eliminates 2 and 8 in the rest of the dark region. So no 8 here. This obviously can't be 3. No 4, 2, or 8. So we could have 1, 5, 6, or 7 there. What are the other possibilities? Obviously, no 2 here. Huh. So, if this is 4 and this is 3, that means this is blue going out there. This is boundary. Well, we already knew this was boundary. So these two are boundaries. We could go orange going that way. That is potentially possible. Hmm. This could be part of that. Okay, so what can this be now vertically? 1, 2, 3, 4, 5, 6, 7, 8 doesn't work because then these are not part of a separate region and they can't be all be part of blue. So this cannot be 5 or greater. Well, it could be 5 if it's that way. 1, 2, 3, 4, 5. 6, 7, 8. Yeah, it's possible. So this can't be greater than 5. That doesn't tell us too much. Hmm. Um, 4 digits adding up to 20 without a 4. I don't think you can ever have 1, right? 1. Well, you can't have 1 and 5 in the same row. So 4, 3, obviously no 4 here. You have to access the 4, which means one of these 3 here has to be 4. 8 then has to be part of this. So then the other 3 digits must add up to 12. With no 4, you cannot have 1 and 5 together. So to add up to 12 with 8 and no 4. Sorry, no 8 and no 4. It cannot have a 1. Can you have 2? 2837 does work. Oh, but there's no 3 involved either. Because of 3 already in the region. That's interesting. So no 3, no 4, and no 8 to add up to 12. Well, you can't have 1, 5, 6 because that would eliminate all possibilities for that cell. I think that's it. So you can't have 4 then. Right, you can't have 4. because you have to have a guaranteed 8 here, because the 4 cannot be in any of the other cells in the blue region. Therefore, the extra 4 has to be in the last digit. So 8 remaining has to be here. And then 20 minus 8 is 12. And we don't have access to 3 or 4 to make that 12 add up. And we don't have 8, obviously. So the possibilities would be 138, which we can't use, 147, which we can't use because of the 4, 156, which doesn't work because this is a 1-5 as a pair. So that would eliminate all, the 156 would eliminate all possibilities for this cell. So that's all 1. 246, 237 requires a 3, 246 requires a 4, and that's it. And 345 requires both 3 and 4. So this cannot be 4 here, which means this must be 3, this must be 4. These 3 digits add up to 20. So we have edge here, edge here. This is all dark. These 3 add up to 20. It has to be 5, 7, and 8. So this is 5, 7, 8 as a triplet here, which eliminates 5, 7, and 8 in the rest of the region. This can't be 5 or 7, it's 6. That eliminates 6 in the rest of the row and column. So this can't be 6 here, it's 8. These 4 add up to 16. This is already 9. 16 minus 9 is 7. So these 2 must add up to 7, so it must be 2 and 5. That eliminates 2 here, so that's 1. This can't be 6 or 8, it's 7 there. So no 7 here. 5 eliminates 5 here. It's 7 and 8 as a pair, which eliminates 7 and 8 in the rest of the row. So no 5 here, no 7 or 8 or 5. So we have 1, 2, 4, 6 remaining. In row 5, okay, we have 8 here. We have 4 digits adding up to 16. So that's 3 more adding up to 8. And we don't have 4 available, so it has to be 1, 2, and 5. That eliminates 1, 2, and 5 in the rest of the region. So this can't be 1 or 5. It's 6. This can't be 1, 5, or 6. It's 7. That eliminates 7 in the rest of the row. So that eliminates 7 here. So this is 8, which makes this 7. No 8 here. No 7 here. No 6 here. So 1 digit adds up to this sum. So this can't be 6, it's 7 or 8. This is part of its own region. We have 1, 2, 4, 5 remaining. That's that again. So this adds up to 3 and 7. We cannot add up to 16 here. We can't add up. This is 18, 15, or 14. This is 11, 14, or 16. So it has to be 14 here. So that's 4. This is 1. That eliminates 1 in the rest of the column. So this is 2, 4, 5. That eliminates 1 there. It's 2 and 5. 7 eliminates 7 here. And 7 here. Okay. So this is 4, which eliminates 4 here. So that's 6, which makes this 1. That eliminates 1 in the rest of the column. 6 eliminates 6 in the rest of the column. 4 eliminates 4 in the rest of the column. Okay. 3 is one of these 2, which it needs to access. This can't be part of the dark because we already have a 7 for the dark, so this is orange. So we have boundary there. 7 and 8. We need access to 4 and a 1. Can this be 5 anymore still? 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is no. So no 5 available vertically. This can't be 2 vertically. Can this be 4? 1, 2, 3, 4, 5, 6, 7, 8, 9. No. And it can't be a full region by itself, so this has to be 1. So this is 1 vertically. No 1 here, no 1 here, no 1 in the rest of the column. So this has a border here and here. Okay. It could be part of blue. One, two, three, 4, 5, 6, 7, 8. Yes, it could still be part of blue. This has to go out here. So we have 8 for separate region here. We can only have 1 more here. So we have 1, 2, 3, 4, 5, 6, 7, 8. We can only have 1 more for blue. So we're guaranteed these are all part of the same region. So this is either part of this region or part of that region there. Okay. 2 eliminates 2 in the rest of this row. So no 2 there. Six eliminates 6 here. 1 eliminates 1 here. So there's no 1 there either. Oh boy. Remain 6 and 7 both eliminate 6 and 7 in the rest of the row. So this is 8, which makes this 7, which makes that 6. That's helpful. That eliminates 6 here. So we have a 4-5 pair in row 6, which eliminates 4, 5 in the rest of the row. So that's 7. Remaining digits, so this is 7. So this adds up to 7 here, and that's 7 there. So this is 2 and 5. So this can't be 5. It's 1. This can't be 1 or 5. It's 6. That eliminates 6 in the rest of the row. We have a 5-7 pair in row 1, which eliminates 5-7 in the rest of the row. So this can't be 5. It's 1. That means this can't be 1. It's 4 or 5. Well, 4 and 5 are both part of dark. So already. So this cannot be dark. It's pink, which means this goes this way to enter the darks. That means this can't be dark here. It's pink. So we have 1, 2, 3, 4, 5, 6, 7 for the pink. So this is adding up to 14. And this is 14, so those are all done. Okay, so let's make sure. We already have marked that. 2 and 5 add up to 7. 3, 4, and 7 add up to 14. 6 and 7 add up to 14. And 2, 5, 1, 8 adds up to 16. So does 5, 7, 8 adds up to 30. And 7 by itself adds up to 7. So we have 4 digits here. That's 2, 3, 5, 6 adding up to 16. So we're done with that. So now it's just basically chaos construction. Oh joy. Okay, 5 eliminates 5 here. 5, 7 as a pair eliminates 5, 7 in the rest of the pink region. So this can't be 5, it's 8. This can't be 5, it's 4. That eliminates 4 there, so it's 6. This can't be 4, 8, it's 5, so it cannot be pink. It must be red. So this is not red there, it's pink. And we are done with the boundaries of the left cell. This can't be 4, 6, it's 5. 8 eliminates 8 here, so it's 7. That makes this not 7, it's 4, which makes this 7. This can't be 4 or 7, it's 8. 7 eliminates 7 here, so it's 5 and 7. This can't be 5 or 7 here, it's 6. This can't be 5 or 7, it's 4. So we're done with the left cell, or the left grid. We just need to be able to figure out the right grid. Okay, so this is 1 vertically. This 2, we don't know. This cannot be 5 vertically because then that blocks this from forming a full region, and we can't take on more than 3 cells. So this has to be 1 or, well, can it be 5 horizontally? Maybe. No. Okay, so we know these are boundaries because we need access to the 3 for the dark region. So if we try to go 5 here or 5 here, the problem is if we try to go 5 here, this is 9, this is 10 cells which can form 1 region but not 2. And we can't contain, well, I guess we could. Never mind, we could have 2. Never mind, okay. That makes this, again, this has to be 6, and this must be 3, because it's 2, 5 as a pair. 6 eliminates 6 in the rest of the column. Remaining digits of row 3, we have 1, 2, 3, 4, 5. No, 1, this cage must be opposite parities. 8 is even, so this must be odd. And this can't be 1 because of 1 in the column. So we have 3 or 5. No 3 here because of 3 in the column. This is different than this, so this must be a different region because we already have a 3 in that region. So this has to go out somewhere. It has to go this way. So we'll make this light, I guess, for now. Huh. Okay. 4, 5 as a pair. Could have 4 there. If we tried to go 4 then 1 here. So the only way to get access to a 1 for blue is going this way, or going here or here. The problem is there are 2 8s in this set of 6, so one of them has to go this way. So we can't go, it can't be pink here if we go 4 1 here, because then we have 1 2 3 4 5 6 7 cells left. So it has to be 4 here, then 1 here. Because if we tried to go 4, 1 here, we're going to have 8 here, and then it's going to must be part of the yellow region, which means we have a duplicate there. So this must be blues there. That's done as a region. We have just yellow left in this region, so that's 8. So that's done as a region. 5 cannot be in the rest of... 5 can't be in the blue region, so this is 4, which makes this 5. No 5 here. Again, we have to have access to an 8, and the 8 cannot be... We already have an 8. 5, 7, 8. Ooh, that's a contradiction. No! 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 It was working so well. Dang it. Ah! No! Ah! Oh, maybe. No, it can't. No, 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 no. Dang it. Ah, that's horrible. Shoot. I feel like this is the solution, but the problem is we have a contradiction. Ugh. Shoot. Oh. Well, we're gonna have to stop here because I don't know how to figure out where to go from this, and this is gonna take a lot longer. And ugh. I'll see you in the next video. Take care.